Special webinar. My name is Debashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions. And today's topic is high availability and redundancy in Cisco networking. So we'll discuss what is the high availability and how to tackle, say, the disaster situation in case of high availability. Say one link has failed. So in that case, how to tackle the situation. So let's begin. So we'll discuss the key concepts in Cisco routing protocols like HSRP, VRRP, and GLBP. So these are the redundancy protocols. This is not a routing protocol. HSRP stands for Hot Standby Router Protocol, VRRP for Virtual Router Redundancy Protocol, and GLBP for Gateway Load Balancing Protocol. So what is the high availability? High availability refers to systems that are durable and likely to operate continuously without failure for a long time. Say a server is running for 24/7, 365 days. So that is highly available. Now, definitely networking high availability is achieved through redundancy, means that you are having multiple paths. Say you are having multiple parallel paths and data is going through all the paths. Say it can be a load balancing situation, or it can be like only one path is being utilized, that is the primary path, and others are backup path. So if the primary path goes down, then other paths will function. So that is the meaning of the high availability and redundancy. Now, Cisco offers various protocols to ensure the high availability and redundancy, include the HSRP, VRRP, and GLBP. Now, these protocols provide mechanisms by which multiple routers can communicate, and if one link fails, then the automatic failover happens. So, what is the importance in networking of this? The importance of high availability is huge in networking, and it cannot be overstated, because a highly available network ensures that access to resources and services remain uninterrupted. Because let's say your web server is running and you are having only one or two links, and if those links go down, all are finished, and you will definitely incur a lot of loss in terms of money. So definitely you will not be able to do that. So in environments where data transmission is critical, say highly available 24/7, your server is running, in that case you should have this highly available infrastructure in place, and multiple links should be there. And delays or downtimes can lead to significant financial losses that I've already told you, and impact your business. By integrating high availability, organizations can actually minimize risk associated with network outages. And definitely it can enhance the user and customer satisfaction. So definitely is highly available network is desired, like your RAID solution when you are having the multiple hard disks in a single server. That is also for the highly availability. And the multiple links, that is also there for the high available situation. Then in the Cisco solutions, in case of the high available, then Cisco offers a variety of solutions designed to enhance network resilience through these protocols like this HSRP, VRRP, and GLBP. HSRP, you cannot say it is a load balancing protocol, it is a pure redundancy protocol like the VRRP, but the GLBP is a load balancing protocol which allow for active passive or active active configurations. Now, what do you mean by this active passive? Active passive is responsible for HSRP. Like you are having one active router, that is a primary router that is sending the data, and other routers are in passive mode, so they are in standby mode, they are not participating in any data transmission. And active active, it is for the GLBP. Then all the routers are actually transmitting the data, or they are doing the load balancing. Now, by using these protocols, organizations can ensure continuous network service even in case of the outages, means the hardware and software failure. And Cisco implementation of these protocols is highly scalable, and it enables organizations to adjust their network architectures definitely as they grow up. Now, the redundancy protocols in depth, HSRP functionality and benefits. Hot Standby Router Protocol is one of the earliest redundancy protocols developed by Cisco, and is a very basic protocol, you can say. It doesn't have so much features as you can see in compared to the others like the GLBP. And it allows several routers on a local area network to work together as a single virtual router. And there is a concept of the virtual router there that I will tell you, because the virtual router is the main part here, who does the interface tracking, who tracks the interface of the active as well as the standby router. And if one interface goes down, the traffic is shifted to the other router by this virtual router. Virtual router is purely logical entity. And in this configuration, one router is designated as the active router to handle the traffic, while others remain in standby mode. VRRP characteristics and use cases. So in case of virtual router redundancy protocol, is an open standard protocol. It is not for Cisco, but it's open standard, and it allows multiple routers to participate in a virtual router group. And it provides redundancy and fault tolerance definitely. And in VRRP, one router is elected as the master and others remain backups. So there in HSRP, we call it an active router, others are standby, but here the name is different only. One router is master, others are backup routers. VRRP's advantages include support for non-Cisco router implementations like the Juniper router. So you are having Cisco and the Juniper. In that case, you cannot use HSRP, you have to use VRRP. And improve load balancing by allowing multiple master routers to service different segments. Yes, it does the load balancing also, but the HSRP doesn't do the load balancing. GLBP features and advantages. Now, Gateway Load Balancing Protocol is another protocol, is a Cisco proprietary protocol that not only provides redundancy but also load balancing. And GLBP allows multiple routers to work together to present a single virtual router to the clients. Again, there is a concept of the virtual router that is in the case of HSRP also, and with the ability to share traffic among them. So it does the load balancing. Yes, it has redundancy also, that if one router fails, then others will definitely take the charge, and it does the load balancing. This enhances resource utilization and ensures that no single device becomes a bottleneck. Now, GLBP dynamically assigns the role of active and backup gateways. So there is an active forwarder, active virtual forwarder concept. So it is a bit complex than the HSRP among the routers, optimizing performance and resilience. So the active forwarder is actually forwarding the traffic. That is the concept of the GLBP. So we can conclude that understanding high availability and redundancy through protocols like HSRP, VRRP, and GLBP is essential for maintaining robust and resilient environments and infrastructure in your network, because this fault tolerance should be there in your network, and it also improves performance by optimizing resource usage. So you are not using every resource same time, but you are load balancing, so it actually improves your performance. And organizations that implement these solutions can enhance operational efficiency and ensures continuous access to critical services, and will boost your business as well. So that is about the theory part that we know for these protocols. And now we can configure, actually in case of CCN environment, you have this HSRP. So let's configure the HSRP here. So as you can see in the packet register, you have these two routers, this router 0 and router 1. And let's say this router 0 would be the active router and the router 1 should be the standby router. And this PC is there where it has an IP address, and say it is forwarding the traffic to any one of the routers, say the active router, that is the router 0. So in case of any failure, the problem will be that the gateway you have to change. Let's say you have to send the traffic to this router 1 now. Now, how can you do it? Because PC set as a default gateway as is router 0. So it will continuously ping the router 0. So you have to manually change the default gateway to this PC. Now, there is one PC. So definitely it is achievable. But if there are 100 pieces, then definitely it will take a lot of time, so you shouldn't do it. So in that case, you should go for a protocol like the HSRP. And here will be somewhere the virtual router, the VR, which will actually facilitate the functioning of the HSRP. It will do the interface tracking of both the routers. And if the interfaces are okay, then there is no failover. But if one interface goes down, then the traffic will be shifted to this router. So let's configure the interface IPs first. Say give the 10001 or any IP. And now use the HSRP configuration. So configure the HSRP now in the interface level. Now there is no command like HSRP. You have to give the command standby. And if you give the question mark, you will see a lot of options like the group number, that is for the 0 to 4095 group. IP is for the virtual IP, virtual routers IP. Preempt, that is another feature where you actually want that this router, say for example, will be the active router always. Even if this router interface goes down and again comes back, then other router cannot be the active router. In that case, you have to use a preempt. Then priority, you have to give the priority level, timers, as well as track and version. So now I'm not giving everything, but I'm giving the group number. So the group number is 10. It should be same in the other router as well. And then you give the, say, the virtual router's IP first. Say it's 10.0.0.100. Then you give the standby, again the group name and the priority. The by default, the priority is 100. Okay, now you have to set priority from 0 to 255. So let's say you are setting as 101. So this router will be elected as the active router. A message will come, yes. So it is going through some stages. Now first is the speak, then the standby, and then it has become the active router, because on other router you are not configured the HSRP. So now you configure HSRP on router 1. This will be the standby router. Now here you do not need to configure any priority, because the priority here will be same like the 100. Only give the standby. Then the group number was 10, and the IP, the virtual IP, is 10.0.0.100. So against the virtual IP, a virtual MAC will also be generated, but we cannot give the MAC address. It will be auto-generated. Now you see the configuration with show standby. You can see the state is still it is peak, means it hasn't been elected as the standby router yet. A message will come and now it has become the standby. So you can check the states also here. And now you see it is a standby router, state is standby, and virtual IP address is 10.0.0.100, active virtual MAC address is this one, and it is actually the HSRP group 0000 and then 0C07. This is a multicast group actually. This is the HSRP protocol. Then the preemption is disabled here. Active router is the other router, that is a 10.0.0.1. Standby router is local, means this router is a standby. Priority is 100, and group name, every information you can get here. And if you go to router 0, that is actually the active router, you again give show standby. You see that state is active now, and you can see active router is local and standby router is 10.0.0.2. So now if you simulate the failure, say I failed the interface of this active router, then see what happens. Go to the first Ethernet port and just shut down this, and see instantly this active state changes to init state. Init is the first state. So it is no longer the active router. And if you go to the router one, it should become yes. It has become the active router from the standby. You can see the message has come. And if you give again the show standby to verify the configuration, you'll see the state is active. Virtual IP address is again 10.0.0.100, and virtual MAC address remains the same. But active router is local, means this router is now the local router, and standby router is unknown because the other router's interface is down. So the router is neither active nor it is a standby router. And you can go to the router 0 as well. You can again give show standby here as well, and you'll see that it doesn't know about any active or standby router. Active router is unknown, standby router is also unknown because its interface is gone. Now, if you again bring back this interface, say again you give no shirt, then definitely it should become the active router because its priority is higher than the other router. So just wait and some message will definitely come. Yes, see, now it is active. Still is active. And standby router, it still is unknown, but it is definitely going to be elected soon. Let me go to the router one. Here also again the standby message should come. Yes. Now it is the standby. And here, if you give the show standby, definitely you see the access standby router is again 10.0.0.2, like the previous one. But now say there are 3-4 routers. There are no 2 routers only, but 3-4 routers. Then if you want that this router, this active router, router 0, will always be elected as the active router, in that case, what you need to do? Then you need to again go to the interface, and then you have to give the standby, then the group number 10, and there is a command preempt. This is the option that you will use when there are more than 2 routers, say 3-4 neighbor routers are there, and you want that always this router will be the active router. Other router, any other router will not be the active router. Say this router interface has failed, and other routers, say router 3 or router 4, will try to become the active router. But if you give this preempt, this will not happen. Means if this router's interface comes up, this will be the active router always. That is the preemption. So these are the features that you have in the HSRP protocol. And in case of the packet tracer, only the HSRP is supported nowadays. And the VRRP is, say, a old protocol now. And GLBP, it is not used so much because of the automation nowadays. And GLBP is supported only in the GNS or EVNG simulators, not in the packet tracer. So in the CCNA level and associate level, you only have this HSRP protocol now. So you have seen that high availability and redundancy is very important in your networking. And as I've told you that if this PC loses access to the, say, the WAN interface or any network here, then it would be disastrous. Because say if this PC is not a PC but is a web server and your website is running, so nobody from the internet will be able to access your web server. And one more thing, your PC, your IP address configuration, let's say you are giving the IP as 10.0.0.50, and the default gateway will not be the router one, means the active router's IP address, but it would be the virtual router's IP, that is the 10.0.0.100. So PC will send the ARP request to the 10.0.0.100, and if you go to the command prompt, you can even ping the virtual router's IP. You can ping, you can see the virtual router is not there, but it is a logical entity, but still the PC is able to ping the virtual router that is somewhere here. And the virtual router is responsible for actually functioning of this HSRP protocol. So that is about the function of the HSRP protocol that I've shown you in detail. And also I've discussed the different VRRP and GLB protocols in theoretical manner also. And I think you should definitely focus on this HSRP protocol more on the CCNA perspective, and the other routing protocols if you're going for the CCNP and others specializations. So this chapter is very important for your Cisco studies and also for your job perspective. So I hope that you have got good knowledge on this topic from this webinar. I thank you all for joining and watching this webinar once again. I'll come with some new topic next time. Till then, keep studying and bye.